this video, we are going to prove if a and b are two real numbers, a is greater than 1, smaller than b, and b is smaller than e2, then the triple integral from a to b, integral from a to b, integral from a to b, x plus y plus z, over line of x plus y plus z over 3, dx dy dz is greater or equal than 3 times b minus a to the power of 3 times a plus b, 2 line of a plus b over 2. If we consider the function f of x equals x over line of x when x is between 1 and e2, the second derivative of this function is 2 minus line of x over x times line of x to the power of 3, which is positive on the open interval 1 and e2. That means the function is convex. And the given integral is 3 times the triple integral a to b, integral from a to b, integral from a to b, f of x plus y plus z over 3 dx dy dz. Since f is a convex function, integral a to b of f of x plus y plus z over 3 dx is greater or equal than b minus a f of a plus b over 6, which is a plus b over 2 divided by 3, plus y over 3 plus z over 3. If we apply Hermit Hadamad inequality one more time, and this time we consider the function as a function of y, the double integral from a to b, integral from a to b, f of x plus y plus z over 3 is going to be greater or equal than b minus a to the power of 2, f of a plus b over 6 plus a plus b over 6 plus z over 3. Now we look at the function f of a plus b over 3 plus z over 3. This function is also convex, therefore the integral of this function with respect to z is going to be greater or equal than b minus a f of a plus b over 3 plus a plus b over 6. That means the triple integral from a to b, integral from a to b, integral from a to b, f of x plus y plus z over 3 dx dy dz is greater or equal than b minus a to the power of 3 f of a plus b over 2. If we rewrite the given integral, it's going to be 3 times, and to convert it in the form of f of x plus y plus z over 3, we have to times and divide the numerator by 3. That's why we have 3 times b minus a to the power of 3 f of a plus b over 2, which is 3 times b minus a to the power of 3 times a plus b over 2 times line of a plus b over 2. If we use the method that we use for 2 variable functions in integral equality number 2, video number 2, we can say for functions of 3 variables, if f of x plus y, f of x, y, z has the second derivative, which is positive with respect to x on interval a, b, second derivative with respect to y is positive with respect to, the second derivative is with respect to y is positive when y is between c and d, and with respect to z, the second derivative is positive when z is between e and f, then I is going to be greater or equal than b minus a times d minus c times f minus e f of a plus b over 2, comma d plus c over 2, comma e plus f over 2. And this is the direct application of Hermit Hadamad inequality on 3 convex functions. If we consider f of x y and z equals x plus y plus z over line of x plus y plus z over 3. The second derivative of this function with respect to x, y, and z on interval 1 and e2 is positive. Therefore, it is positive on interval a to b. And if we rewrite inequality star for that, we have I greater or equal than b minus a to the power of 3. F of, instead of x, y, z, we have to put a plus b over 2. Then the numerator would be 3 times a plus b over 2, and the denominator would be line of a plus b over 2, which is the same as 3 times b minus a to the power of 3 times a plus b over 2 times line of a plus b over 2. Thanks for watching.